Welcome to Math2Go. Today we are looking into trigonometric functions and in particular to this amazing equality here. So sine to the power of 2 plus cosine to the power of 2 equals 1. And this is true for all x from the real numbers. So below you can see both cosine and sine. And I did my best to draw them. And you can see that if cosine is 0, then sine is 1. Vice versa, if sine is 0, then cosine is -1, and so on. So they're both alternating with each other between 1 and -1. And what is really interesting here is if at any point x you take the squares of both sine and cosine at this value x, for example here, you see that if you add them up, you are always getting 1. And this fact actually can be seen here on the top in this unit circle here, because we have a triangle with degree 90 degree here. So the Pythagorean theorem applies here, and this means we can take the squares of this line and add them together to get the length of this line here to the square to the power of 2. Because we have the unit circle here, this is just 1, so the root of this is also 1. And here this is well known that we have sine and cosine here for these two lengths of the triangle. So let's prove this equality. So this is really easy to prove. We prove this with very easy facts, and you should be able to understand it. If you have any questions, please leave a comment below. So first we just define the function f of x equals sine to the power of x plus cosine to the power of 2. And then we take the first derivative here. And we have two products here, which are adding up here with this plus. So we can use the product rule for sine to the power of 2 to get sine times cosine, and then plus the same vice versa. So again, sine plus times cosine. So this is like you're getting this as a derivative for sine to the power of 2 using the product rule. We are doing the same for the second part. So for cosine to the power of 2, we are doing exactly the same because it's just equals cosine times cosine, and we are applying the product rule here as well, which gives us cosine x times, and the derivative of cosine is minus sine, and then exactly the same thing because we are just doing the same for the second part, for the second cosine. So we have cosine times minus sine x. So all in all, you can see we have sine x times cosine plus sine times cosine. So this is just 2 times sine of x times cosine of x, and here we have 2 times cosine of x minus sine of x, 2 times. So actually this just simplifies to 2 times sine of x times cosine of x minus 2 sine of x times cosine of x, and this is just 0. So we know that the first derivative of this function f, which we defined here, is 0 always, independently of x. So from this it follows f is a constant function, because we know if the first derivative at some point, or if the first derivative is always 0, then we know the function is always constant. So this is a constant function. It always has one value for any x. So the second objection here is just, what is actually f of pi? We can actually insert any point x, but pi is one of the most simplest ones, because if we insert pi here in the function, we have sine of pi to the power of 2 plus cosine of pi to the power of 2. And so pi is supposed to be here. And for pi we know that the sine of pi is 0. So this means if we square it, we still have 0. And cosine of pi is -1. And -1 to the power of 2 is 1. So all in all we have f of pi is just 1. So we can conclude f is a constant function, and if we insert pi we have the value 1, meaning f is always 1. So from this it follows f of x is 1 for all x from the reals. So I guess this was really an easy proof. If you still have any questions, please leave a comment. And if not, see you next time. Thank you.